Now, let's talk about the force. Now, the concept of force. Force is defined as a push or pull experienced by an object. So, a force that push that an object it experiences or a pull can be of certain kind of energy. So, the force is usually described in terms of its size and the direction. So, a size can be known also as a magnitude. So, a force is described the main of these two. The size that the magnitude that it uses to push or pull an object and the direction that it push or pulls an object to. So this unit of force is Newton. Uh, it's abbreviated by N. Now the 1 Newton can be defined as the amount of force required to give a mass of 1 kilogram and acceleration of 1 meter per second square. So that's what the definition of Newton as a main is a unit of force. So as you can see that a force to obtain a force is equals to the mass of 1 kilogram or of any amount times acceleration. So mass times acceleration equals to force. Now, the instrument that is used to measure the amount of force is exerted on an object. It's called a spring band. So this is the main instrument that is used to measure the amount of force that an object can exert. Now, a spring band can be used to measure small forces. It consists of a coiled spring fixed to the other end with a hook at the other end. So the body is placed upon that the hook and it stretches. Now the amount of stretching, the distance through which the springs is stretched is in direct proportion to the force applied by the bands. So that's what is the spring bands, how it works. Now the types of forces, there are too many types of forces. The first one is the fundamental forces and the second one is non-fundamental forces. Now the fundamental forces, these are the basic forces which in nature that can be explained by the action of another force. So these are the main forces and they are the basic forces. We have four of them. The first one is the force of gravity. Now the force of gravity is the pull by which the earth, moon, and the other large bodies attract other other objects towards themselves. So this is the proof that these heavenly bodies attract other bodies. Now it is commonly referred to as the weight of an object that is attracted. Now the force of gravity has the following properties. The first one is that it pulls the object towards the center of the earth, and the second one is that it is direct proportional to the mass of the object. This means that the greater the mass, then the greater the pull of gravity. Now, the fundamental forces which we have, the other one is electromagnetic forces. Now, these forces include both electric and magnetic forces generally, and the properties of these forces include that it may attract and it is attractive and repulsive in nature. So, attractive means that it attracts the two bodies, and repulsive means it contradicts the two bodies. Now, the other one is that if the central force and then it is stronger than the gravitational force in terms of that the magnitude, and then it is also a long range force. It operates means it operates in a very long distance. Now the other fundamental force is the strong nuclear force. Now this is the force which holds the constitutions or the subatomic particles of the atomic nucleus. Now it acts within the nucleus of an atom. So the property of this strong nuclear force, the first one is basically an attractive force, uh, different from electromagnetic. That electromagnetic is attractive or repulsive, but the strong nuclear force it is only attractive, and the other one, it is non-central force, so it doesn't act on the center. And the third one, it is stronger than a gravitational force. And the last one, it is a strong range force that operates only to the distance of up to 10 to 14 meters. So this is the strong nuclear force. The last one is the weak nuclear force. So this is the force which operates only in a certain nuclear processes. So the properties of this weak nuclear force is that it is much stronger than the gravitational force, but weaker than the strong nuclear force and the electromagnetic force, as you can see that. And it also acts in the small ranges of up to 10 to 17 meters. So that's all about the weak nuclear force. So that's all for this video. We've talked about the forces, the types of forces, basically the fundamental forces that will force them, the gravitational force, strong nuclear force, weak nuclear force, yeah, and the electromagnetic force. So that's all for this video. I hope it's clear, guys. See you in the next video.